Hello everyone, I hope everyone is doing well. Today I want to discuss equations with rational exponents. So if you're in grade 11, this is probably, and doing the IB, this is probably something you've dealt with already at this time of year. Our time of recording is middle of February. So I have a few students that have been struggling with this a bit, so I thought I'd make a video on it. So here we go. Let's first identify by what they mean with rational exponents. So remember, a rational number you can just write as a over b. Okay, that's a bit thick. You can just write it as a over b, right? So it's any fraction. So any rational number can be written as a fraction like that. Okay, and you can see here that in the exponent position here, we have a rational number. Okay, 1 over 2. It's a fraction, right? So you could also write this as equations with fractional exponents. Okay, it's the same thing. So that's what we're looking at. Okay, and the basic premise is this. So currently we have this thing over here. We have x to the power 1 over 2, and what I don't have here is the instruction would be solve for x. Okay, that would be the instruction. So what we want is x is equal to some answer. That's our main goal, right? But the thing is here, x is to the power of 1. Okay, I don't have to write that, but that's the main goal. I want x to the power 1 is equal to something. All right, so that's our main goal. So what we do is we inverse this fraction. Okay, and what we do is we say, okay, I currently have x to the power 1 over 2, like that. And I need to say, okay, I want it x to the power of 1. So to do that, I have to multiply by the inverse. Okay, I know I did my two 2's differently over here. Sorry, I get confused with them sometimes, but yeah. So this is a 2, that's a 2. Let me neaten this up. Sorry, I have a really bad habit with that. But essentially, the main point is we inverse this. Okay, we inverse this fraction. So here we had 1 over 2, and now we just have the opposite. That 1 went up there, down there, sorry, and the 2 went up there. Okay, we've just inversed the fraction. Okay. Hopefully everyone's following so far. And what we do to the left, we have to do to the right. So let's think, what did we do now on the left? We've added this, okay? So what we have to do is on this side, we have to do the same. All right, we have to say 4 to the power of 2 over 1, because that's what we have over here. Okay, these should be the same exponents. All right, so the left actually works itself out nicely, right? So these fractions are going to cancel because remember our exponent rules, these end up timesing. If you have a power to a power, they times, right? So you can cross cancel and you can even use your calculator here. But remember, because we've inversed this fraction, this will be to the power of 1. And if you do this in your calculator, you shouldn't need a calculator because it's just 4 squared. But if you need a calculator, that's okay too. No issue with that, to be honest. And we get 16. Okay, so I don't have to write x to the 1, but I just did that for emphasis. Okay, so this is the basic procedure. Okay, so a very important part is what I've circled here in orange, is we need to get rid of this fraction. So we need to inverse whatever fraction is there. So if it's 2 over 3, x to the 2 over 3, we're going to have to times this thing by 3 over 2, because we inverse the fraction. Okay, but we'll do a few examples so you'll see what's happening. Okay, so this is the basic premise of equations with rational exponents. It comes down to this, essentially. Okay, but what is important is there's 3 little checks or 3 little things that come up often that are a bit different to this rule over here. Okay, it's a bit different, but let's not panic. Let's look at the 3 cases. All right, so the 3 cases come up like this. Okay, so we'll go through these ones. But there's 3 different concepts here. Okay, so you'll see we're going to go through all of them, but these are the cases. Okay, and you'll see how we identify them. All right, so these are the specific cases. We'll go into them now. So it's important that we have these 3 checks at the back of our mind because they come up often. Okay, so keep an eye out for these. This is why I'm making a specific point of these before we actually get into mixed problems. Okay, so the first case is this one. Okay, so what you might be saying is, okay, well, Brandon, I just apply my rule, right? So what I do is, this is my question. So what I do is I just inverse this fraction. So this will be 2 over 1. And what I do on this side is I also do 2 over 1, right? So the thing is, nothing is inherently wrong with these steps. If you do this in your calculator, you'll get x is equal to 9, right? So remember, this thing has to be a bracket in your calculator. So we get 9 here, okay? So the problem is, if you plug this 9 back, right? If you now replace this with a 9, right? If you in your calculator, if you do 9 to the power of 1 over 2, what you'll get is you'll get positive 3, right? Instead of negative 3. So what happens here in this case, right, is there is no solution. Okay, so what we should do is not even do these steps over here. And the rule is whenever you have 1 over an even number, okay, so any even number, 4, 6, 8, 246, whatever it is, right? If you have an even number, 1 over an even number, and on this side you have a negative, it is not possible. So we say no real solution. There's no real solution in the real number system. There's no real solution. Okay, so this is something you have to keep an eye out for and identify. Okay, so you have to pause when you do all these questions and look for these 3 checks. That's why we're doing them now. Okay, so because I showed you, if you do the method, you get an answer, right? But that answer is not valid. Okay, so the rule is whenever you have 1 over an even number, okay, so 1 over an even number, right? So if you have x to the power of 1 over even, and that is equal to anything that is negative, there's no real solution. So this is all we write. No real solution. Okay, that was our first check. All right, the second check is a bit different, right? So here we have x to the power of 2 over 3 is equal to negative 4. All right, so in terms of our first check, we don't have 1 over an even number, right? So firstly, we have 2 at the top, and at the bottom 3 is odd. Okay, so we can go into this using our normal method. Okay, so we have x to the power of 2 over 3. Remember, we inverse this fraction, times it over there, and we do it on this side over here, 3 over 2. All right, so what I want you guys to do is now put this in your calculator. And when you put this in your calculator, what you'll see is, I'll actually show you what we get. All right, here's the calculator. So if we put this in our calculator, we say negative 4 to the power of 3 over 2. And we get math error. So now we've done nothing wrong here, okay? The issue is what's essentially happening here is whenever you have an even number here at the bottom, what you're doing is you're taking a root of this number, okay? So what you're doing is you can't take an even root of a negative number, okay? So for example, you can't say negative 4, right, to the power of 1 over 2, okay? Because remember, you can rewrite like this. So the case is whenever there's an even number here at the bottom, then you can't do this, okay? But this is a nice check, okay? Because you see how this one, when we go through the method, we can't go further from this step. We have to stop here. Okay, this isn't our final solution, but we have to stop here, okay, because we get a math error, like I showed you on the calculator. So this is a nicer check, because once we do the method, we shouldn't really call it a check. It's kind of just one of the special cases, because it's not a check. I mean, you don't have to check. It works itself out. Okay, you with me there? So here, what we can do is we can actually just cross this out, and we can say no real solution again, right? Because there is no real solution. So whenever this one, again, it's not something you have to memorize. It's not a check you have to memorize, because it sorts itself out. But whenever you have a even number here at the bottom, okay, and you have a negative number in this bracket over here, right? So essentially here you're taking an even root of a negative number, which is not possible. Then we write no real solution. Okay, so what I hope you guys have noticed so far is when we're dealing with negative numbers, you got to be a bit careful. If you see here in our first check, we also had negative numbers. Okay, and you got to be a bit careful with these negatives. So take a pause, and when there's a negative number, just be a bit careful. Okay, so This again is a nice check because it sorts itself out. We don't have to memorize anything. It just gives us a math error, but don't panic. We can just write no real solution. This one was an issue because we have to memorize it because the method actually gives us an answer, but the answer is not valid. So there's no real solution. Okay, so remember our rule. If we have 1 over an even number and we have a negative on this side, no real solution. Okay, so again, maybe not have been clear on this side, but it's only when there's a negative number here. Okay, that's kind of what I was pointing out over here. I don't know why I crossed that out, but let me make it explicitly clear. So when you have 1 over an even number, that can never be equal to anything that is negative, right? So any negative number. So that can never be any negative number. Okay, and when we have this, we say no real solution. So that's what you would write there. Okay, then the next special case is quite special, all right, because it's a bit different because there are no negative numbers. Okay, you'll see here, there are no negative numbers. Okay, so this is the question, and you see there's no negative numbers, right? So you'd be thinking, okay, there's no issue here. And yes, you're all right, there is no issue here. But the thing is, this is just a bit of a different method, and I'll explain why. Okay, so when we tackle this, we do the exact same thing that we've been doing. We inverse this. 3 over 2 is equal to 25 to the power of 3 over 2. And you'll see here, we got to be careful, right? Because on this side, we got an even number, but there's no negative, right? So if you put it in the calculator, this isn't going to give an issue. But the thing is, we need to be careful here because when there's an even number here at the bottom, in our next step, we're going to have to write plus or minus. Okay, we have to write plus or minus. Okay, so let's see how that works out. So here we know this is going to cancel and give us x to the power of 1, or just x. And on this side, if we put this in our calculator, so remember that bracket it is important. So we say bracket 25 to the power of 3 over 2, and we get plus or minus 125. Okay, so both of these answers are valid solutions of x, right? So essentially that's x is equal to 125 or x is equal to negative 125. Okay, so you could write either one of these. Okay, but the main point is there are two solutions here. Okay, I know if you do this in your calculator, let me show you what happens if you do this step in the calculator. All right, remember the bracket, it is important. So we get 25 to the power of 3 over 2. So if we do it in the calculator, we only get 125. But we need to identify what I've circled here in blue. If this is an even power here at the bottom, then we have to do plus or minus. Okay, and the reason is let's plug in these solutions that we got here. Let's plug in these different ones into our x over here. Okay, let's plug them in and confirm they're both valid. You don't have to do this, but this is just to show you. Okay, so if I say 125 to the power of 2 over 3, what am I expecting? 25, right? No problems. Okay, but what happens if I put negative 125? I should also be getting 25. And I do. Okay. So those are the 3 checks that you need to keep an eye out for. Okay. So I know it might not be the most clear at the moment. Okay, which is fair enough. So let's get some practice. Let us try some examples. So these are going to be mixed. Okay, so I do encourage you to pause the video as I write the problem down and see if you can do it yourself and keep an eye out for those checks. All right, even I struggle to remember these checks sometimes, so I might even forget, and you might be right. Okay, so also if I make a mistake, please correct me in the comments. But anyways, so we have x to the 1 over 2 is equal to 4. So again, this is a mixed practice, and let us check what is happening. All right, we know we don't have a negative number here, so we're not too panicked. But we need to still be careful. So it's not going to be check 1 or 2 because there's no negative number complications. But we still need to be careful because it could be a third check. But anyways, if we do this, remember we just inverse that fraction, and what we do on the left, we have to do to the right. So we just get x is equal to 4 squared, which is 16. All right, nice and easy. All right, then let us do this one. Let's do x to the power of 1 over 2 is equal to -4. And alarm bell should be ringing. We got a negative here. Okay, and we know immediately that here we have 1 over an even number is equal to a negative. We know that is not possible. So this is no real solution. This comes from check number 1. There's no real solution. Okay. Hopefully everyone's happy so far. Nice and easy, I would say, relatively so far. All right. 1 over 3 is equal to 5. And again, we just inverse our things over here. There's no negative numbers we need to worry about. So this is just 3 over 1 is equal to 5 to the power of 3 over 1. So here we just get x is 125. All right, feel free to use your calculator if you don't know what 5 cubed is. No issue with that. All right, let's check the next one. It's x to the power of 1 over 3 is equal to -5. All right, we might have to be a bit careful because we have a negative, but 3 is an odd number. So we know immediately it's not no real solution. But let's see with our second check. Remember, the second check resolves itself. Okay, so we know first check, no issues. We're fine with the first check, but let's just keep a bit of a lookout. Maybe the second check comes in here. Okay, but remember the calculator will tell us what's up. Okay, so we just standard inverse both sides. So this becomes x. And I will show you, I will do this one on my calculator, show you that there will be no math error. So we just say -5 to the power of 3 over 1. And we get -125. So no issue. All right, there wasn't a math error. Okay, so this is a valid solution. And if you want, you can put in -125 over there, and you can confirm that the left-hand side is equal to the right-hand side. All right, hope everyone's doing good so far. Let's keep going. Now we have x to the 1 over 4 is equal to -2. And immediately we see we have 1 over an even number. So remember, any even number, not just 2. So 2, 4, 6, 8, 10, 12, all of those. If we have 1 over an even number, this is not possible if it's equal to a negative. All right, so let me be clear on that, sorry. So if it's 1 over an even number and we have a negative on this side, it is not possible. So again, we say no real solution. So it is, I mean, it is possible, but not in the real number system. That's why we say no real solution. If you're dealing with complex numbers, then there will be a solution, but that's not in the math core syllabus. But let us continue. Here's the next question. It's equal to 4. And there's no negative, so there's no issues. So we have x 2 over 3. We inverse this, 3 over 2 is equal to 4 to the 3 over 2. Okay, so we got to be careful now, because here we have an even number. Okay, so we got an even number here, so we know it's going to be plus or minus if we don't get a math error, but we're not going to get a math error because there's no negative there. Okay, so I encourage you that you check here. If there's an even number, immediately put the plus or minus so you don't forget. Okay, so this side will sort itself out as x, and then this side I will show you on the calculator. I don't know if you could see where I was pointing. Sorry, I had it on the wrong screen, but I hope it wasn't too much of an issue. Let us, if we do this in our calculator, on the right, remember we only get a positive value. Okay, so, but we know that it is plus or minus. Okay, let me shift to this. We know that it is plus or minus 8. That is a terrible 8. Plus or minus 8. All right, and you can confirm by putting the answer in there if you would like. But remember, I encourage that if this is an even over here, put this immediately over here so you don't forget. Okay, we are moving a bit fast, but I hope everyone is following. Let us move over to this one. Next to the 3 over 2 is equal to -4. So again, we just inverse. We don't have 1 over an even number, so it's okay, but we might have to be careful. 3 over 2, 2 over 3, if we inverse that, is equal to -4, 2 over 3. Okay, so are there any issues here? No, there won't be any issues. So this just leaves us x, and this one, look, we do have a negative number, but if you put this in your calculator, all right, so we don't have 1 over an even number here. So we know that we can keep going, and now we just need to see, well, are we going to get an error? And if you put in your calculator, you can't see what I'm doing. Now you can. If we put this in the calculator, 2 over 3, we get this. Why did I put this answer in if it was such a terrible number? Okay, it happens. Sometimes we don't get the nicest number. But the main point is this was possible. Okay, they didn't give us a math error. So it met the first check because we don't have 1 over an even number. And it met the second check because we didn't get a math error in the calculator. So the answer, I guess I'll put it to 2 decimal places, 2,52. 2,52. 2,52. And again, I don't have to put a plus minus because this is an odd number. So I don't put a plus minus here because that is an odd number. So yeah, that's the only valid solution. Obviously, we've rounded it. Yeah, obviously that's not the nicest number, but it is what it is. We still follow our steps and we get the right answer. Okay, even though it didn't look nice. Let us try this one. X to the power of 2 over 3. I'm starting to answer the question already. Is equal to -64. Okay, so hopefully this is getting a bit boring how easy it's getting. We just inverse this side, and then this side -64, 3 over 2. All right, so if you put this in your calculator, you'll see we get a math error. Because remember, there's an even number down here, negative there, no bueno, that is not okay. So we say no real solution. Okay, no real solution. And where are we now? Okay, let's look at some questions that are perhaps a bit more challenging, but just remember our base steps that we were using, our base steps. Okay, so this might be quite a leap, but again, let's just look at our base steps. Okay, if some of you are looking at this and saying, oh no, that's okay. It is quite different to what we were doing, but let's not panic. Right, so this thing is very different. I will not lie, it is very different to what we've been doing. But the main point is we have x to some fraction thing is equal to a constant on this side. So let's try get it in that form. Okay, so we need this thing essentially by itself. So we just get rid of this. So right now it's just basic algebra for x to the 5. And then we take that 10 to the other side and we get 64. All right, no issues so far. Now I want to get rid of this 2, divide both sides by 2. So I get 4x to the 5 is equal to 32. And now this I can rewrite using my exponent laws as x to the 5 over 4 is equal to 32. And this is exactly what we've been doing, right? So yeah, this step, exactly what we've been doing. So whenever you get something complicated like this, try get it into a form that you know and that you have been doing. Okay, so if we have a look here, we know that check 1 doesn't apply. So we just inverse. So here we get x. If we put that in our calculator, we get, what do we get? 4 over 5. We get 16. So x is 16. Okay, and again, I don't have to put a plus minus because this is odd. All right. Now, what I haven't exactly covered so far, I might have more examples on the back of this piece of paper, but what I haven't covered yet is negative exponents. Okay, I haven't covered negative exponents, but you'll see that it's literally the exact same. All right, slightly different. I wouldn't say exact same, slightly different, but almost exactly the same. So x to the power of negative 3 over 5. All right, and remember our main goal is to get x to the power of 1. Sorry, my voice. So what we do is we inverse the fraction, right? But I want to the power of 1, positive 1. So do you see how this has to be a negative? Because remember, this thing is going to times this thing. So the two negatives will cancel, this 5 will cancel, that 3 will cancel, so like this, that, and you're just left with x to the 1. Okay, so let me remove all this canceling stuff. Might look a bit weird. And on this side, we have 1 over 1,000, sorry, 1 over 1,000, yeah, 1,000, negative 5 over 3. So this side we have x to the power of 1, and on this side we just plug that in our calculator. Minus 5 over 3, and we get 100,000. So x is 100, I'll write this neat there, 100,000. Okay, and again, this is an odd number, so we don't write plus or minus. We don't do that. Okay, so don't let these negative powers confuse you, right? So it's not that there's a negative in there, right? So these negatives don't really apply to our checks. Okay, our checks apply irrelevant of the minus in the exponent. Okay, so the minus in the exponent. All right, our rules are still the same. Okay, that wraps it up for this video. So I'm pretty sure I have covered everything. There are definitely a few more examples with these negative exponents I could possibly do, but I feel like that covers everything. So I hope that if you were struggling with this, it is a lot more clear. And if you were slightly unsure, you are now sure. Okay, so I hope this video was helpful. But otherwise, thank you for watching, and I'm wishing you all the best.